polynomial function and end behavior. And what I gave you was really everything you need to know is in that box. Okay, so we're going to have to highlight this in. So when you have an odd degree polynomial, notice I don't say odd function. Odd function mean all entirely are different things. An odd degree polynomial mean your exponent is going to be an odd number, the highest exponent. Okay, the highest exponent is an odd number. So for example, so when we look at odd degree, yeah, that means the highest exponent is odd. Okay? And if you have a positive leading coefficient, this is how your graph is going to behave. On the left, you're going to go down, and on the right, you're going to go up. For an odd degree, you have one end go down, one end go up. For an odd degree, that's what you're going to have. Okay? For an even degree polynomial, either both ends go up or both ends go down. So that's how you know if you have an odd or an even degree. Okay? Now let me give you an example. What is an odd and what's an even degree polynomial? If you look down here, look at your exponents. You don't have to look at the rest. Just look at the exponent, the biggest exponent. In this case, the biggest exponent is a 5. That is an odd degree. Are we okay? If you look at the next example right here, you can see that I have an exponent of 4, 3, 2, and a constant. Well, the highest exponent is a 4. That is an even degree polynomial. Do you guys see that? So we don't look at the exponent and say, well, all of them have to be even. No, no, no. Only the highest exponent. That's your degree. Are we okay? So this is an even degree right here versus this is an odd degree. Because between an exponent of 3 and 5, 5 is bigger. So that's your odd exponents. That's your degree. Are we good? Okay. So now, this is what they tell you is, if your leading coefficient is positive, you have a positive leading coefficient. Now, if you said, Ms. Tran, what does that mean? The term that have the biggest exponent, you're going to have to look at the number attached to that term. In this case, you have a negative value. Do you guys see that? If you don't have a number, it's a 1. So in this case, you have a negative 1. This tells you that your leading coefficient is negative. So in this case, you have an odd degree and a negative leading coefficient. So that means your end behavior, yeah, it's going to go, wait, why is it going weird like that? Yes, it's going to go, left end go up, and then the right end go down. Okay, I will show you a little trick to help you check. Is that good? But this is basically the idea behind it. If you have an even degree, I think this is easier. Remember, if you have an even degree, you can look at like quadratics. Yeah? So you have a parabola that opens up or a parabola that's open down. When the parabola opens up, the number in front of x squared is positive. That's your leading coefficient. Is that okay? So if your leading coefficient is positive, your graph is going to open up, so both ends will go up. If your leading coefficient is negative, both ends will go down. That means the parabola, as an example, will open down. So these are the way that your end behavior is going to look. Okay? If you can memorize that, that's great. Now, what if you're like, Ms. Tran, I cannot memorize that? Nope, no way. Okay, I'm going to show you a shortcut to help you out. Okay? Not really a shortcut, it's just you have to do it. Let's say I have an odd degree. So let's say I have a function. You don't need to write down, but you need to look up so I can explain it to you, okay? Let's say I have 2x cubed plus 5x squared minus 4, something like that, yeah? So the highest exponent is this 3. That is an odd degree. Yeah? My leading coefficient is the number in front of that term, which is 2. This is called my leading coefficient. It is a positive number. So therefore, my graph is going to look like this. The left end go down and the right end go up. I don't know what happened in between, but I know that's what happened at the end. Okay? How do we check, Ms. Tran? What can I do if I don't remember this? This end means your x is a negative number. This end means your x is a positive number. Is that okay? On this end, that's the left end. So x is negative. If you want to check, plug a negative in there and check. Just in this term, just this one. So if I plug in 2 and I plug in a negative value to the third power, see what that sign is. Well, a negative to an odd power is negative. A negative times a positive is going to give you a negative value. And that's why your graph is going down. You guys see that? That's how you check. Okay? Now, what if I want to check the right end? We call this the right end behavior. Then plug in a positive. Because on the right, that's when x is approaching positive number. Well, a positive to any power is positive. Times 2, that's still positive. And that's why this end go up. Because it's got to go to the positive value. Are we all right? So that's how you checked if you don't want to memorize this. Are we good? Okay. So now that we have that out, let's take a look and determine the end behavior. Okay? And then there's some language that you need to know how to write. So we're going to have to work on that. It says, determine the end behavior, fill in the blank, write your answer using limit notation. Now, I can see that this is x to the negative 5. So I'm going to write this first. My degree is a 5. Okay? My leading coefficient is a negative value. I'm just going to write negative. Based on the diagram here, I have an odd degree because my degree is a 5. My leading coefficient is negative, so I'm going to look at this one. You guys see that? So my end behavior needs to look like this. Now look at your end behavior. I graphed this out so you can see. My end behavior, the left end go up, just like what it showed me here. And then my right end go down, just like it showed me here. Is that okay? Yes? I want you to be able to visualize it. We don't know what happened in the middle, but the end is always going to stay consistent to this chart. Now, this is what they're going to test you on. So you're going to have to make sure you understand the language, okay? As input value is the x value. As input value of f of x increase without bounds. Underline that word for me, please. Input increase without bounds. This tells you x approach infinity. That is how you translate this out. If input value increase without bounds, that means your x, input is x, go to infinity. What happened to your output value? Your output value is your y value, which is your function. Where is your function going? Well, you can look at this one right here, because that's what we have. As x go to positive infinity, which is this one, your function go to negative infinity, because your function go down right here. You guys see that? So that means your function here, based on the diagram, is going to negative infinity. Yeah? Now you gotta have to write it out. So you can see it here. I'm gonna write this for you, okay? Now let me write here and then I'll write this. So as input value increase without bounds, output value of f(x) decrease without bounds. Decrease because the function go to negative infinity. Yeah? If it says increase without bounds, mean positive infinity. Does that make sense? Okay. Let's move on to the next one. But I want to write the limit notation. And let me see if I need to introduce that for you. Because I want to make sure you have that as well. Yeah, let me make sure. Yeah, I do want that for you. Okay. They're going to ask you to write the limit notation. So this is how you write it. Okay? You're going to write ILM. That's limit. So write that for me, please. On the bottom of that word, you're going to write X going to. And that's where you got to fill in. Because it says input value increase without bounds, that means X go to infinity. Are you guys good? At the end of the LIM, you're going to write the name of the function. The name of the function is f of x. And you got to tell me where it goes. But we cannot put an arrow. We have to put an equal sign. Well, here you can see that as x go to infinity, that means as your graph move right. Because x going to infinity means your function is going to the right. Your graphs go down. Down means your y value is getting more and more negative. So that's why we write negative infinity. Okay? So here, this is how it reads. The limit as x increase without bounds, output value f of x decrease without bounds. That's how you write that. They're going to ask you to do that on the AP exam. Is that okay? But we're going to be working on this. It's going to look very weird at first, I guarantee. But as you do it, you're going to see that it's the same thing over and over again. Okay? All right, we're going to do the next one. As input value of f of x decrease without bounds. So when it says decrease without bounds, that means x go to negative infinity. Input is x. Decrease without bounds means x go to negative infinity. Where is your output going? Where's your output value going? Well, output is f of x. Yeah? You can look at this table, or you can look at the graph. As input value decrease without bounds, that means we're looking at the left. This n. So that's the negative x. This n. Your function is going up. That means your f of x go to positive infinity. The way we say that is output value of f of x increase without bounds. Okay? And now we're going to write the limit notation. We're going to write the limit notation. So you're going to write LIM, x go to. It says the input value decrease without bounds, so x go to negative infinity. Where is f of x going? You look at your graph. Negative infinity means left. Look at the left end. Your function go up. That's positive infinity. Okay? You only have two, either the left end or the right end, when you look at the infinity. So you got to know, hey, are they talking about the left or the right? Okay? And what's my function doing? Are we all right? Okay. I want you to do example 2 for me, but I want you to tell me what the degree is. What's the leading coefficient is? That means is the leading coefficient positive, negative, and then see if you can tell me the end behavior. Okay? Go ahead and do that right now. Go ahead and do that right now. So hopefully you have your degree is 4. So that's an even degree. Your leading coefficient again is negative. Yeah? So if I'm looking at the degree, that's an even degree. I'm going to go over here because that's a negative leading coefficient. So that means my function, the left end will go down and the right end will go down. And you can see that right here, right? Here's your left end. Left end go down. Right end also go down. So that's why your graph looks like that. Okay? So now we're going to have to translate this. Try to read it again, okay? And underline it and translate it for me. Okay, input values increase without bounds. What does that mean? And then where's your output value going? Okay, so translate that for me. And if you don't know, you can look at the answer. The answer is already here because you have an even degree and negative leading coefficient. So they already give you the answer here. Do you guys see that? The problem is that you have to memorize that, right? But you don't have to, okay? The trick that I show you, it will work. Is that good? So here, input value is x. Increase without bounds means x go to infinity. So where's your output going? Output in this case, the name is g of x. Where's g of x going? Well, increase without bounds means we're looking at the right. The right end, the function, the y value is negative, it's going down. So that means it's going to negative infinity. Negative infinity means decrease without bounds. Without bounds means it's go on forever. Okay? So if I were to write the limit notation, it would be the limit. You got to write the x to infinity down here. Okay? Make sure it's directly down there. And then you're going to write the name of the function. Your function is going to negative infinity. So you write equals negative infinity. Like that. Is that good? Yes? Okay, we're going to do the next one. As input value of g of x decrease without bounds, that means your x go to negative infinity. So we're looking at the left end right here. Output values, that's your g of x, is doing what? Well, on the left, my function decreases again. So my function is g, is going to negative infinity. So that means the function g decrease without bounds as well. Okay, so what's the limit notation? The limit is lim, x go to negative infinity. The name of the function is g of x, go to negative infinity. How are we doing? We okay? Yes? Now, Ms. Tran, what if they don't give me the graph? How am I going to do that? Number one, you can look at this. Or number two, I show it to you already. You can test. So I'm going to write this here, yeah? Test and behavior. You're going to test it for me. Hopefully you have enough space, yeah? Okay, so no graph. This is what you do. You're going to look at the left end first. Left end. That's when x go to negative infinity. That's the left. Okay? What you're going to do is you're going to look at the terms. You got to see the terms, so hold on. I'll zoom it in so you can see, yeah? You guys see this term right here? That's the term that is the most important one. That's the term that controls everything. Okay? No, it's not the term that is the first one you see. It's the term that has the highest exponent. And in this case, the highest exponent is a 4. Okay? You're going to go after the sign because you just need the signs, people. Is it positive or negative? That's all you need. So you're going to take that term and you're going to take negative 2 and you're going to plug in a negative right there for me. Just test because this is a negative. Test a negative value. That's any negative to an even power is positive. A positive times a negative. So you have a negative here. Now you times a positive. A negative times a positive is a negative. That tells you your function goes to negative infinity. That's what this means. That's it. Do you guys see that? So you don't have to memorize it. Okay? How about the right end? The right end, that means your x go to positive infinity. So test it again. Take the negative 2 and then plug in a positive signs. I don't care about a number. I just know I'm after the signs. I have a negative 2, so that's a negative number, times a positive to any power is positive. So a negative times a positive, that's a negative. This tells you your function goes to negative infinity again. That's it. Bless you. Does that make sense? Yes? So that is going to